All right, guys, we're gonna hop into this Unit 9 test review, which covers section 5.1 through 5.3. So, looking at some different trig expressions, we'll look at simplifying them, and like in 3 and 4, verifying them. And then we'll get into all our different identities, our different formulas, sum and difference, half angle, double angle. We'll work a few problems on those. Yeah, let's hop right into it. So over here to the left, I've got my fundamental trig identities that I'll use when I start to simplify these expressions. This first part is from section 5.1, so let's get started with that. We have sine times secant times cotangent. And so a general like thought process of this is, let me change everything to sine and or cosine. All right, so sine's already sine. Secant, I can use the reciprocal identity, and I can write secant as 1 over cosine. So let me just start to write out what I have. So it'll be sine times 1 over cosine, using the reciprocal identity for this. And then cotangent, using the quotient identity, I can write that as cosine of x over sine of x. And then from here, I'll just look to see what I can combine or cancel out. So sine cancels out with sine, cosine cancels out with cosine, and the result I get is just 1. First one down. Okay, we're going to number 2, and we start off with the fraction. A common mistake I see is that people will maybe say like, okay, tangent, I can use the quotient identity. So on top, they'll write, in this case, sine over cosine on top of this fraction, which isn't wrong, but it just makes it more complicated than it needs to be. The way you kind of think about this, tangent equals sine over cosine. So what I'd want to do is have like my main type of fraction here, and if it started in the bottom, I would move it to the top if I do a reciprocal, or in this case, if I do quotient, I'll put like sine on top and cosine on the bottom of it, if that makes sense. All right, so this is my tangent, sine over cosine. I've already got sine down there, and then I'll go to secant, which secant can come up, and using the reciprocal identity for that, it can become cosine squared, since we have 2 of them. All right, and this is what I am left with. So again, I'll look and see what is canceling out for me. And I see that I can cancel out a sine and a sine. And then I have 1 cosine here, so this cancels 1 of the 2 cosines I got on top. So what I'm left with now is just a cosine. And this is good because I've got it simplified to one expression. There's no fraction, and yeah, this is what I got, cosine x. On to number 3. So for number 3, we actually want to verify this. On the left side, we got secant x over tangent of x minus tangent of x over secant. Secant of x, and this equals cosine x cotangent x. All right, so we basically want to verify that this does equal this. And by verify, it means like, all right, show me how in the world we go from what we have on the left side to being able to equal what we have on the right side. So before I start going at this, and we got a few different techniques we use to solve these, my mind is thinking that on the left side, I see that I've got fractions, which I don't have on the right side. So somehow I'm going to want to get rid of these fractions. And then I notice that I got 2 separated terms by a minus sign. But when I go over here, I've got 2 terms, but there's no separation. It's 2 terms being multiplied together. So I'm thinking I'm gonna need to make this one fraction where I get one like combined set of terms, and then I'm gonna need the fraction part to cancel out to where I'm just left with what I have on top. So a lot of times what'll happen is once I turn this into one fraction that has the same denominator, um, just naturally I should be able to get it to where I don't have a denominator. I'll be able to cancel it out or substitute it for something, and then I'll be able to get what I have on the right side. So to start off, we need to get a common denominator for both of these terms. All right, and so that common denominator will have both pieces of like each denominator combined, meaning my common denominator will be tangent times secant. So I think, okay, this one already has tangent. What does this side need to be multiplied by? Well, I need to put secant in the denominator. Now, if I do it on the bottom, I'll also need to multiply the top by that same thing. Right? So now this denominator will have secant times tangent. As I go to this side, it's already got secant, it needs tangent. So I multiply the top by tangent and the bottom by tangent. Because essentially I'm just multiplying this by 1. So what I get is secant times secant, which is secant squared x. That's the top. And then on the bottom, I have secant times tangent. And I'll tell you what, I'll leave this separated to start off. So that's my first term. As I go to the second term, I've got tangent times tangent, which is tangent squared, divided by secant times tangent. All right, notice the denominators are exactly the same, so I can put them together and write it as one fraction. So I've got secant squared x minus tangent squared x divided by that common denominator of secant x tangent x. Right, I'm gonna run that line down. Okay, and so now as I start seeing I got secant squared, tangent squared, I'm thinking that maybe that will end up equaling something. So since it's squared, I go to my Pythagorean identities. I go to the one that has secant. Notice it also has tangent. And if I'm looking at what I have, I've got secant squared minus tangent squared. I'm thinking from this identity, if I subtract tangent and put it over here to be with secant, I'll get that secant squared minus tangent squared. Let me show you what I'm talking about. So just over to the side, we're about to use the Pythagorean identity, which it starts off as 1 plus tangent squared x equals secant squared x. And if I subtract tangent squared, these two will end up canceling out, and what we'll be left with is what we see. 1 equals secant squared minus tangent squared. And sure enough, I see that secant squared minus tangent squared equals 1. So I can do substitution for that. So I'll pick back up with my problem. And now I will substitute that secant squared minus tangent squared to be just 1, because the identity shows me that that is what secant squared minus tangent squared equals 1. And now this is over my common denominator of secant x times tangent x. And so if I go back and look at what we were wanting to show that this could come out to equal, I see that if I do reciprocal identity, I'll get what I needed to equal. So if I do reciprocal for secant, 1 over secant equals cosine, and then 1 over tangent using reciprocal identity equals cotangent. So I get what I was looking to get using the reciprocal identities. And we just verified that these two expressions are indeed equal to one another. All right, on to number 4. So number 4, we got cosine of x divided by tangent of x plus secant x. And we want to show that this equals 1 minus sine x. All right, so again, I'm looking at the left and I'm seeing what changes with the right side. And so for this one, I'm thinking I won't be able to really do anything initially. Maybe I can convert tangent to be, using the quotient identity, to be sine over cosine, but that's not really going to help me solve it because I'll have a fraction plus secant. I'm not really going to be able to cancel anything out. So my next strategy I'm thinking is I got tangent and secant together. And if we recall, we just used that identity where we had secant and tangent together and we were able to substitute it to equal 1. So I'm thinking if I can make that identity happen, I'll be able to do some substitution again on the bottom. And then normally when you like maybe get this to equal 1 somehow, everything else will just kind of fall into place once I attack this first part. So clearly I'm thinking, okay, I got tangent and secant, but I need to have them squared. So what I'm thinking is I need to multiply by the conjugate, meaning I need to multiply by these same terms, but if I change the sign, I'll be able to square them both without having to worry about the middle terms. So again, the conjugate is both of the same terms, and I'm not going to have enough space. Let me rewrite it. Actually, I can do it on this side. So multiplying by the conjugate means I'm going to have the same terms, so tangent and secant. And instead of keeping the same sign, I'm going to change the middle sign. And this will be nice for me because it'll help me cancel out the middle terms. All right, so since I'm doing it on the bottom, I'm also going to have to multiply the top by that as well. Okay, so just to be clear, we're multiplying the top and the bottom by tangent x minus secant x. All right, and then I'll come below. I tell you what, let me write it again so it'll look a little neater. We're going to do cosine of x times tangent x minus secant x. And then we've already got tangent x plus secant x. And remember, these are together. And then we're going to multiply that by tangent x minus secant of x. All right, so let's multiply the top. First, I need to do some distributing. I got cosine of x times tangent of x, which is cosine times tangent. And then I've got cosine of x times secant of x. So minus, because it's negative there. And then we got cosine x secant x. And then this is all divided by, here we need to FOIL, but remember the middle terms would cancel. That's why we chose to multiply by the conjugate, because we knew the middle terms would cancel. So all we really need to do is first times first, which is tangent times tangent, so tangent squared. Then we do last times last, which is secant times secant. A positive times a negative is a negative, and then secant times secant is secant squared. All right, and then we see, just like we had before, using that same identity, if we substitute it and solve it for 1, we see that secant squared minus tangent squared equals 1. That's the same thing we, well, it's in a different order. So it'll just be -1. Let me show you that. All right, so let's go back to this Pythagorean identity. We have, let me use a different color. We're using Pythag. We're going to try to use it. So we're using Pythagorean identity. And we're going back to this one that has tangent and secant with it. All right, so this is the identity that we start with. what we want to do is make it look like this one right here. So it's slightly different because the last time we had secant being positive and tangent being negative. Really long story short, if we change all of the signs, this will come out to be -1. I'll come back to the start and show you how we're going to get that. So this time, to get it to look like this, we need tangent to stay positive, meaning we need to subtract secant this time. So we'll subtract secant from both sides. These secants cancel out, and what we have is 1 plus tangent squared minus secant squared equals 0 because nothing else is over there. And so now I need 1 to go so it looks just like this. So I would subtract 1 from both sides. And we get tangent squared x minus secant squared x equals -1. All right, so this equals -1. And then, while we're doing this, let's go ahead and see if we can cancel some terms out here. So if I'm thinking, quotient identity says tangent can be sine over cosine. That's going to get that cosine to cancel out. So we got cosine x. And then, using quotient identity, we get sine over cosine. That was tangent. Then we got minus cosine. And then the reciprocal of secant is 1 over cosine. And again, I've got these identities on my sheet, so I'm just pulling from these reciprocal identities and these quotient identities here. All right, so it looks like those will cancel out as well. And then this is all being divided by -1. All right, so cosine and cosine cancel. Cosine and cosine cancel here. So what we're left with is sine of x minus 1 divided by -1. If I divide both of these terms by -1, we change the signs. So what I get is negative sine of x plus 1. And then if I wanted to make it look like that, I would just change the order. So 1 is in front minus sine of x. And we just verified that the left side does come out to equal the right side. All right, let's get on into some formulas. So we'll go on to number 5. These are sum and difference formulas to find the exact values. So you'd want to have your unit circle handy. Let me grab mine. And like I say, I work with these a lot, so I've got the unit circle memorized pretty good. You should too at this point of the course because we've been working with it so much. I actually got a student's project. I couldn't find one of mine. Just as we get going, I'll start just to show you these exact values. I haven't graded this. This is actually somebody else's, so hopefully everything's right. We'll check it as we go. All right, so first one, we got number 5. We're wanting to find sine of -7 pi over 12. All right, now if this angle was on my unit circle, I would just write the exact value. And just to be clear, the exact value is the coordinates. It's the coordinates for these. Okay, so the parentheses on the outside of the unit circle. So I know sine is y, and I might just want to have this handy. I know sine of x equals the y coordinate, cosine of x equals the x coordinate, and then tangent is a combination of both of those. It is y divided by x. All right, so if I just looked at my unit circle and I saw that sine was on this angle is on my unit circle, I would just be able to get the y coordinate and answer it. But -7 pi over 12 is not on my unit circle. So what I need is a combination of two angles that will allow me to use one of the sine, sum, or difference formulas. So we converted these angles in our notes. Let me see if I got that over here. Yes. We already went through the trouble of converting some of these radian measures into being like fractions over 12. So we can clearly see what two we should subtract to get -7. You might have to do that for different denominators if you want, or like I say, you can always just convert this to a degree measure if that's what you prefer to work with. Let's see if on the angles I've got, we can find two angles that'll give me what I'm looking for. So I want to get -7 pi over 12. I'm thinking maybe we can do, let's see, 6. So I think I need to get some bigger angles. Let's go over here and get some bigger angles. So this one would be, if I multiply the top and the bottom by 4, 8 pi over 12. Or if I do this one, 5 pi over 6, and I multiply it by 2, I get 10 pi over 12. And I'm thinking I can do 10 pi over 12 and 3 pi over 12. Those two angles are 7 pi over 12 away from one another. All right, so what I mean is, I think those are the two that I will go for. Ten and 3. Okay, so I'm gonna do sine of, and we need the smaller angle to come first. So 3 pi over 12 minus the bigger angle, 10 pi over 12. And that's how we're going to get a negative angle here. So like I say, I'm not familiar with what these two are, just like this. So when I reduce them, or if I look, I can see what these really are. So 10 pi over 12 is 5 pi over 6. 3 pi over 12 is pi over 4. So those are the two angles that we're going to use. This one is pi over 4 minus, this one was 5 pi over 6. All right, that's what we're going to put into our formula. So we got sine of pi over 4 minus 5 pi over 6. All right, so we're doing the difference formula. Let's go back to my sheet here. We're doing the difference formula for sine. So I need sine of A times cosine of B, cosine of A minus cosine of A times sine of B. I'll write them out on this first one, and then we probably won't need to write them again. So sine of A times cosine of B minus cosine of A times sine of B. Just from the formula. So I go on my unit circle and I get these exact values. Sine of a 45 is 2 over 2. Cosine of a 30, and this is in the second quadrant, so it's negative. This exact value is negative root 3 over 2 minus cosine of 45 times sine of a 30 in the second quadrant will be positive 1/2. I got a positive times a negative, so that result will be negative root 2 times root 3 is root 6. And then in the denominators, I got 2 times 2, which is over 4. This denominator will also be 2 times 2 over 4. So I'm going to go ahead and write them together. So we got root 2 times 1 is just minus the square root of 2. And this is as simplified as I could get it. So this is my result. Now, if you chose two different numbers, you might have like negative root 2 minus root 6. It's the same. We just changed the orders. Depending on your angles, it could just be like flipped around. But the value that, like, if we put this in our calculator or if we changed how it looked, the value is the same. Not necessarily that the numbers are in the same order, but the value is the same. All right, let's go on to number 6. Number 6, we got sine of 19 pi over 12. And again, this is over 12, so I need two angles that I can add together to give me 19. 10 over 12 and 8 over 12 give me 18. I'm thinking I need to know what this middle angle is right here. So we got 3 over 4. If I multiply this by 3 over 3, I get 3 times 3 is 9 pi over 4 times 3, 12. So if I do 3 pi over 4 and 5 pi over 6, I'll get the angle I'm looking for. Just to be clear, we're going to do sine of 10 pi over 12 plus 9 pi over 12, which is really 5 pi over 6 plus 3 pi over 4. Or you say 150 plus 135. All right, so this time we're doing the sum formula. And we're doing sum of 5 pi over 6 plus 3 pi over 4. Now, all I'm doing is the formula. The difference between this formula is we'll add the angles instead of subtracting them because this is the sum formula for sine. I won't write this step out. I'll go straight to the exact values, but we're basically doing the same thing. I'm just following the formula, additions, sine. I'm just following that formula. I'm gonna go ahead and put the exact values in. So first we got sine of 5 pi over 6, which is 1/2, times cosine of angle B. So cosine of this 45-degree angle is negative 2 over 2, plus we got cosine of A, which is negative 3 over 2. And then we got sine of B, which is positive 2 over 2. The result for the first two is negative root 2 over 2 times 2, which is 4. The second one would also be over 4, so I'm going to go ahead and write them together. And then I got negative root 3 times positive root 2, which is the square root of 6. And this is my answer. Number 7. We got cosine 7 pi over 12. All right, that's similar to what we did before. We got negative 7 pi over 12. I'm thinking maybe I just change the order of these two, and then if I subtract 10 minus 3, I'll get what I'm looking for. So let's just go ahead and play off of that. So basically, if we do cosine of 10 pi over 12, and we subtract 3 pi over 12 from it, we get that 7 pi over 12 that we need. And we've done these before. I know that 10 pi over 12 is 5 pi over 6 minus 3 pi over 12 is pi over 4. So these are the two angles we'll use. Cosine of 5 pi over 6 minus pi over 4. So this is a 30 and this is a 45-degree angle. Like I say, I'm gonna go straight into writing these exact values, and the formula changes slightly for cosine, and we're doing the difference formula. So we got cosine of the first angle times cosine of the second plus, remember the sign changes with cosine, it's different. Just remember that, sine of the first times sine of the second. So let's get our cosines first. Cosine of 5 pi over 6 is negative 3 over 2. Cosine of 45 is 2 over 2, plus from the formula, sine of the first angle is positive 1/2, times sine of the second angle is 2 over 2. Negative root 3 times negative 2, root 2, times just root 2, comes out to be negative root 6. 2 times 2 is 4 again, plus two positive numbers, so it'll stay positive. 1 times root 2 is just root 2, and then 2 times 2 again, it's over 4. So this is what I got. And like I say, you could have root 2 plus root 6 depending on the angles you chose. The value of the expression should come out to be exactly the same. Number 8, cosine negative 5 pi over 12. And look, these could be degree measures. I feel like we feel pretty good about the degree measures, so I just opted to choose some radian measures. But like I say, you can convert these to degrees. I tell you what, for this one, let's convert this to degrees, see what we come up with. All right, so negative 5 pi over 12, if we want to convert it to degrees, we multiply it by 180 degrees divided by pi. Then we'll simplify. The pi's will cancel. Then we could use our calculator to simplify this. I've got negative 5 times 180, and then I'll divide that by 12. And I see that this is negative 75 degrees. So let's work with that one for this one. And this is just another way to do it. We could have picked 2 angles in the radians. That will work 100%. This also works too. Convert it to degrees, and let's work with the degrees. So negative 75 degrees. So 2 angles from a unit circle that give me negative 75 degrees. Let's see, maybe we could do, what if we do 120 minus 45? What do we get? 75 degrees. So if we reorganize it and we do 45 minus 120, that's how we get that negative number. Sorry, you couldn't see that. So 120 and 45 are 75 away. If we make the smaller number 45, if we put that in front and we subtract the bigger number from it, we get that negative result. So we are going to use, we're going to do cosine of 45 minus 120. So we're going to cosine formula, and we are doing the difference formula. So cosine A times cosine B plus sine of the first angle times sine of the second angle. My cosines first. Cosine of 45 is 2 over 2. Cosine of 120 is negative 1/2. And then I'm just following the formula. So it's plus sine of 45, it's 2 over 2, times sine of 120 is positive 3 over 2. Root 2 times negative 1 is negative root 2. In the denominator, 2 times 2 equals 4. This denominator will also be 4, so I'm going to write it together. And then I got plus root 2 times root 3 is the square root of 6. And that should be my answer. All right, number 9, a couple more of these. And on these last 2, we'll look at tangent. So number 9, we've got tangent of 255. So 255, not on my unit circle. I need 2 angles that I can probably add to get 225. So I might get my calculator out and let's see, 255. What if we do 135 plus 60 won't be enough. Not quite. What if we do 135 plus 120? We get 255. So these are the 2 angles I'll use, 135 plus 120. There are other combinations you could use. These are the 2 angles that I will use. So we got tangent of 135 plus, what did we say? I forgot just that quick. 120. So we're doing the sum formula for tangent, adding 2 angles for tangent. So we use just tangent of the 2 angles. All right, so I'm gonna write this formula out so you can see it. We've got tangent of the first angle plus tangent of the second angle divided by 1 minus tangent of the first times tangent of the second. All right, and before we get too far, I'll tell you what, let's go over to the side and let's see what tangent of these values are. So remember, tangent of an angle equals y divided by x. So off to the side, tangent of 135 is y over x. So I go to these coordinates, 135, and it's a 45-degree angle. So I'll get negative root 2 over 2 for my x, root 2 over 2 for my y. So what we get is 2 over 2 divided by negative root 2 over 2. Now, these numbers are exactly the same, so what happens is they cancel out to equal just negative 1. Okay, so that's going to be my tangent of 135. This is going to be negative 1. This one's also going to be negative 1. Let's see what tangent of 120 is. And look, we wrote these down on our notes. We went on and got it. 120 is a 60. Tangent of a 60 should be root 3. Since I'm in the second quadrant, I know tangent is negative. So tangent of 120 should be negative root 3. Let's go ahead and just do the work since we're here and see what we get. So tangent of 120, again, y over x. At 120, the y coordinate is 3 over 2. The x coordinate is negative 1/2. So I got 3 over 2 divided by negative 1/2. For this one, I need to keep the top, change the multiplication, and then I'll flip the bottom to be negative 2 over 1. The 2's cancel, and I'm left with negative root 3 over 1, so just negative root 3. All right, so these tangent of 120s are negative root 3. Okay, so let's write what we got. So tangent of 135 is negative 1 plus, or I should have put minus, but I'll go ahead and keep it moving, plus negative root 3 divided by 1 minus negative 1 times negative root 3. And from here, it's honestly just simplifying things. The top I'll write as 1 minus root 3 divided by, these two negatives become positive. So it'll be 1 minus root 3. All right, I forgot my negative there. So negative 1 minus root 3 over 1 minus root 3. Okay, and these are not the same. It's not as simple as being able to cancel it out. So this is my answer. Let's simplify it though. All right, so for the simplification process, I normally would want to multiply by just root 3 to get rid of this radical in the denominator. But in this case, I got to multiply by the conjugate, kind of like what we did before. So my conjugate of the denominator will have the same numbers, 1 and root 3, except I'll change the sign. So instead of minus, I'll make it plus. Now, if I multiply the bottom by it, law of equality means I'll have to multiply the top by it because all I'm doing is multiplying by negative 1. All right, so on the top, I got a 4. So first times first is -1. Outer times outer is -1 times √3. Inner times inner is -√3 times 1. Last times last is -√3 times +√3. So that'll be -3. The square root of 3 times the square root of 3 equals the square root of 9, which comes out to equal 3. So that's how we got that 3. This is all divided by, remember with the conjugate, the middle terms will cancel. So I only need to do first times first, which is 1. The sign will be negative. And then again, √3, last times last, √3 times √3 will be the square root of 9, which is just 3. I combine my like terms. -1 minus 3 is -4. I got 2 negative √3s. And then this is all divided by 1 minus 3, -2. And then from here, it's just simplifying. Last step. So 4 and 2 are divisible by 2. Since this 2 is negative, it'll change both of these signs. All right, so these two cancel out. I get 1 here, and for this one, I get +2. These two cancel out as well, and for here, I get +1. So I won't write the 1, but what we get is 2 plus 1 times √3. Divided by 1, I don't need to write the denominator 1 because this is what I'll end up getting. Right? Don't stress out. If you get here, this is a good answer. The rest of it is just simplifying. If you get here, this is like pretty much full credit for the points, but we do need to simplify, so this is my full answer right here. 2 plus √3. Let's see, we got one more tangent problem. The tangent problems are a little bit more tedious. You won't have a ton of these on the test, so don't start freaking out, but let's look at tangent. So I need two angles that'll give me -π/12. If I go back to that sheet I had, I see I can just do 3π/12 and 2π/12. The bigger one needs to come out to be negative. So if I organize it like tangent of, actually let me stay here and then I'll go back down. Tangent of 2π/12 minus 3π/12, I'll get that -π/12. So what are these angles really? 2π/12 is really π/6, so that's a 30, minus 3π/12, which is really π/4, so that's a 45. So how about I write the degree measures? That'll help some of us. So π/6 is 30 minus 45. We're really just wanting to find tangent of -15 degrees. So this time we're doing the difference formula for tangent. It's right here. So I'll write what our setup should look like. Tangent of the first angle minus tangent of the second angle. And then we'll do 1 plus both of those tangent angles. So we got tangent of the first angle minus tangent of the second angle divided by 1 plus tangent of the first times tangent of the second. So let's get these exact values. Now I could do what I did before, but if we just recall, tangent of a 45 equals 1. In the first quadrant, it'll be positive, so tangent of 45 will end up being 1. Tangent of a 30 will be √3/3. So tangent of a 60, which we did previously, we got just the square root of 3. Okay, so the 30s will be root 3 over 3. All right, let's put these in and clean up our expression. All right, so I got root 3 over 3 minus 1 for tangent of 45 divided by 1 plus root 3 over 3 times 1. So we multiply these two together, we just get the square root of 3 over 3. So let me write that so it'll look a little cleaner. All right, and then I need to get a common denominator to be able to put these pieces together. So this is my answer. We got to simplify it. What I'll do is multiply this one by 3 over 3. And I'll multiply this one by 3 over 3 also. So we'll be able to get them together. So what I got here is root 3 over 3 minus 3 over 3 divided by 3 over 3, that's this one, plus root 3 over 3. Then I'll put them together. So since this is a square root and this is not, I can't like say this equals 0 because that just wouldn't be true. I got them keep them separately, but I can write them as one fraction as I just put them next to each other. So that's the top. And then on the bottom, I've got 3 plus root 3 all over the same 3 because the denominators are together. So next I'll come down and I'll keep change flip. So I'll keep the top, root 3 minus 3 over 3. I'll change the multiplication, and then I'll flip the bottom, 3 over 3 plus root 3. And here I see the 3's cancel, and I'm left with root 3 minus 3 over 3 plus root 3. This is my answer. I have this square root in the denominator, so we need to continue to simplify that. We're going to do the same thing as we did before, where we multiply by the conjugate to get rid of the denominator here. Now, if you got here, don't freak out. This is pretty good. We got our answer. It's just not in the most simple form. So we're going to continue to simplify it, but this is your answer. You got here, this is pretty good. Don't start stressing out about the simplification process. There's a very minute, small detail in the grand scheme of things. Like getting here is pretty good. So let's multiply by the conjugate of the bottom. So we got 3 and the square root of 3. Those are my two terms. To get the conjugate of the bottom, we just change the sign. So instead of addition, we're going to make it subtraction. If I do it on the bottom, I've also got to do it on the top. And so essentially, I'm just multiplying by 1 because that's what this simplifies to. And let's FOIL it. Let's see if I can fit it over here. All right, so first times first is 3 times root 3. And I'm not going to be able to fit this. Let me go down. I'm not going to be able to fit this. All right, so let's go down here. All right, so first times first, root 3 times 3 gives me 3 root 3. Outer times outer is root 3 times root 3. A positive times a negative. That'll be negative square root of 9. The square root of 9 is 3. Inner times inner is negative 3 times positive 3. And then last times last is negative root 3 times negative 3. Did I say that right? Negative times negative makes it positive 3 root 3. All divided by, remember the middle terms will cancel out on the bottom. So just 3 times 3 minus, because the signs are different, root 3 times root 3, which is the square root of 9, which is 3. Combine our like terms. So we've got a total of 6 root 3's this time. And then with my numbers, I got negative 3 minus 9 is negative 12 plus 6 root 3's. All divided by 6. Each term has a common multiple of 6. So I can reduce by dividing every number by 6. This will give me negative 2. This one gives me 1. This one gives me 1. So after some good work, final answer is negative 2 plus 1 root 3 divided by 1. We don't need to write that denominator of 1 because this is what it comes out to equal. All right, like I said, don't freak out about the tangents. There aren't a ton of these on the test. All right, let's keep going. A few more problems.